Factoring trinomials whose highest power is greater than 2 is possible so long as the highest power is even, the next highest power is half the highest power, and the third term is a constant. Okay, so what does all that mean? Let's do an example to show you. So far we've been factoring trinomials that are really quadratic expressions where the highest power is 2. But now we're going to try to factor some things that have a power that's greater than that. So, for example, we're going to factor the following trinomials. The first one, x to the 8th plus 2x to the 4th plus 1. Okay, so look at this sentence that we read up here. The highest power is even. So the highest power of this expression, x to the 8th plus 2x to the 4th plus 1, the highest power we see there is 8, and it happens to be even. And then it says the next highest power is half the highest power. So the next highest power that we have there is 4, right? Okay, and then the third term is a constant. So that's exactly what we have here. All right, so we can factor this as the product of two binomials very easily. So when we had an x squared there instead of an x to the 8th, we had x times x, right, in terms of our factoring, but now x times x would just give us x squared. We need x to the 8th, so we're going to have x to the 4th times x to the 4th, right? X to the 4th times x to the 4th is x to the 8th. You add the exponents. Okay. All right, so that takes care of that issue. Now, treasure map wise, we want factors of 1 that add to 2, okay? And we're adding everywhere, right? That's the other thing. So both of our factoring numbers are going to be positive. And then, so factors of 1 that add to 2, that would be 1 and 1, right? Okay, so we have x to the 4th plus 1 times x to the 4th plus 1. Or we could also say it x to the 4th plus 1 quantity squared. Okay, so let's check this. So if we FOIL this back through, what do we get here? X to the 4th times x to the 4th is x to the 8th. X to the 4th times 1 is x to the 4th. X to the 4th times 1 is x to the 4th. That's what we get for our outer and our inner there. And for the last, 1 times 1 is 1. Okay, so we have x to the 8th, and then for our middle term, x to the 4th plus x to the 4th is 2x to the 4th plus 1. Is that the original statement that we started with? Yes, it is. So this gives you a flavor for how you can factor trinomials that have a power higher than 2. Okay, now let's try another example here. H to the 18th minus 5h to the 9th plus 6. Okay, again, the highest power is even. That's important here. And so if we take that power and cut it in half, that's h to the 9th, right? And we notice that's the power on the middle term, right? So h to the 9th times h to the 9th is h to the 18th, right, when we have the exponents. Now, for our signs, the last term there is positive 6. So we know both of the factoring numbers have to be either positive or they both have to be negative. The middle term is negative, so we know that both of them are going to be negative. Okay, now we need two factors, factors of 6 that add to give us negative 5. Okay, so there aren't very many with 6, right? We have 1 and 6 and 2 and 3. And if both 2 and 3 are negative, negative 2 minus 3 is negative 5. Okay, so we're going to have h to the 9th minus 2 times the quantity h to the 9th minus 3. And let's check this. So again, start with what we ended with, h to the 9th minus 2 times h to the 9th minus 3. And I'm going to bring it down here since we're almost out of room. H to the 9th times h to the 9th is h to the 18th. H to the 9th times minus 3 is minus h to the 9th. Minus 2 times h to the 9th is minus 2h to the 9th. And then negative 2 times negative 3 is positive 6. Okay, clean up the middle term. Negative 3h to the 9th minus 2h to the 9th is minus 5h to the 9th plus 6, which is the statement that we started with. Okay, great. So in conclusion, if you've got a trinomial with leading coefficient 1 that has a power that's higher than 2 and even, and if the power on the middle term is half of that, this can still factor very easily, as we've seen in these examples.